All right, so here we are going to start, continue along with our JavaScript exercises from Launch School's JavaScript book. And we're working on flow control now. So let's see what this entails. All right, so what does the following log to the console and why? So I'm not going to type this out. I'm just going to say it, what it is, by looking at it. And I believe this is going to log. It's going to log how can this be true to the console, and that is because the condition in the if statement here will return a truthy value, which would be, I believe it'll be 5, and then the true branch of the if statement is going to run, logging this to the console. So let's go ahead and try it first, and we'll see if that it actually is the case. What? Okay, not sure what happened there. But let's. I think I can just run it from here. So yes. So if you look down here, you can see 5. Well, a equals 5, return 5, and then uh, so if a, and then here's the if statement. How can this be true? Is returned because a is a truthy value. So let's look at the answer. See if I am wrong or right. The output is, how can this be true? This is an example of the way JavaScript coerces any value to a Boolean value. Right. So the value 5 is coerced to a Boolean value, I guess. Truthy or true. In this case, the global variable a declared on line 1 is used as a conditional expression for the if statement. Okay. JavaScript evaluates the value of variable a, which is 5, to be truthy. Therefore, the true branch of the if statement is evaluated, and how can this be true is logged to the console. So yeah, that's pretty much what I said. So yes, so let's do the second one. What does the following log to the console and why? So here we have b equals 0. So if b, so the question is 0 one of the values that is truthy or falsy? And we can test that out. Well, I guess this is kind of the test right here. Is there another way to test it? I don't know. I mean, we might be able to write like a if zero return true or something like that. Uh, it doesn't like that that way of doing it. If I do that, no. If zero. Hmm. Oh, you know what? It's probably not gonna like return. Maybe because we're not in a function. So let's try if 1. So yeah, 1, 2, 3, 4. Those all return true. Um, this does not return true. 0 does not. So 0 is probably falsy. I think it is in JavaScript. 0. I think the empty string is that also. Yeah, because empty string 0. I think null. Um, not a number. I think undefined is falsy. Um, can I do that? Yeah. So we could do the opposite to get true here. So the opposite of nan. So yeah. So I believe those are the falsy values in JavaScript. So this will log console log. It is not true. And again, for the same reasons of the first exercise there, um, we have, the condition is gonna get evaluated, and the false branch of the if statement is gonna get executed. Now I should note that the flow control here is the if statement. That's what we're practicing with, just to see how that works. So the output is it is not true. This is an example of the way. So this is another example. Blah blah blah. Same wording, just a different. You could pause there if you want to really read it again. What does the following log to the console and why? So I should also note that these exercises were in the text of the section. That's why I wrote them out. They weren't actually exercises proper, I guess, for the book, um, but they are. I felt they were important to think about, so I added them as my own exercises. What does the following log to the console and why? So let x. So we're gonna declare x up here with no initial value. All right, and so um, it looks like what I think what this is an example of is that we can actually declare or we can actually assign a value in a condition statement. I think we probably could actually declare a value as well. So this is going to log how can this be true? This is actually going to be truthy. So I think the confusion is, wait, aren't we comparing to see if x equals 5? And in English, that might be what we're doing, but in JavaScript, no, we're actually assigning the value of 5 to x. And so if we do that in a condition, as the same way that we saw a, or was it, I don't remember where it was, the same way that we saw a is um, the when we declared it with an initial value, it returned the value itself. So that's going to happen here as well. So when we assign x to 5, it's going to return 5, which is truthy, which is then going to run this. So this is, again, coercing this expression, x equals 5, to a truthy value, um, to true, to a Boolean. And then it's going to run this. So yeah, so to fix this, we would obviously do double equals or triple equals. Triple equals is probably preferable, and in which point, I think it wouldn't work anymore. So let's go ahead and try this in the console, and we'll see if it does work. Yeah, how can this be true, right? X equals 5, what? So let's try to just do that, and do this, and it's still true. And I think that has something to do with x being undefined up here. So let's say if we did this, it is still true. Oh, yeah. No, now I'm a little bit confused of why that is still true. Oh, because we actually didn't change x. That's why. So I think actually now that I think about it, that's the problem that we're experiencing. So let me fix that real quick. Let's see. All right, get a new node session. I don't really know how to do it other than to get a new node session working. So there we go. It is not true. So that's the triple equals fixes that problem. So let's see what the answer is. Yep, the output is how can this be true? This is an example of the way it courses. So the global variable x is declared on line 1 with no initial value. And then we assign the variable x to the number 5 as the conditional expression for the if statement. So yeah. So that is that. And there's a note I put here. Avoid assigning variables as if statement conditions because x equals 5 can look like x equals 5, and or another person may see this as an error to correct it. So even if we did really want this to be assigned in the condition of the if statement, someone coming along later is going to be like, wait, do you really want this, or do you want double equals or triple equals or whatever, right? So like maybe someone forgot to put an equal sign. That's probably a common thing. All right, so let's move on. What values do the following expressions evaluate to? All right, so now we're learning about logical operators here. False or true and false. So we're going to do the what's in the parentheses here first, and it's going to be true and false is going to be false. So false or false is going to be false. So let's go ahead and check that. So yep, we can see down here, it is definitely false. True or 1 plus 2. So 1 plus 2 is 3. That's going to be truthy. But actually, we don't even need to do that because this is going to do what's called short circuiting. And as soon as it hits this true, and then it says or, it knows that only one of them has to be true. So it's just going to return true. And there you go. Same thing here. And the other aspect of this is, okay, so normally in when we're comparing logical operators like this, the last one to be evaluated is what's going to be returned. And so you might think 3 would be returned here because it would be the last one to be evaluated, but because of the short circuiting, it's actually true. Same thing in this case. This case, 3 is going to be returned, and which is truthy. And true is not going to be returned because it's not even going to get evaluated. So 1 plus 2 gets evaluated, 3 is truthy, that satisfies the OR logical operator, so 3 gets returned here. And you can see that it actually does get returned there. All right, so true, and then because this is AND, both sides need to be true in order for it to be truthy or return a truthy value. And in this case, that both sides are true, this is going to be 3, and that's going to be true. And since this is the last one, to be evaluated, 3 is going to be returned. There we go. We got false. Okay, so right there with a false and we know that this is going to return false. So it's going to short circuit this. We're not even going to evaluate this side of the expression, so it's going to just return false. 3 and true. So again, this is similar to this one in that both sides are going to have to be evaluated, and since the true is the last one to be evaluated, this one's going to return true. So I think that these two examples, so this one and this one, right? Both of those examples, I think could be confusing if you don't understand what gets returned from logical operators, right? So because logically there's no difference between them, but yet they each return different things. So that could be confusing if you're comparing Boolean values with integers or something like this, or other truthy values. So that's why we're learning this. Okay, now we're doing comparison operators, I think. Yeah, comparison. And we're going to see what they return. So 32 divided by 4 is greater than or equal to 129. Obviously, that's going to be false. So it's going to evaluate what's in parentheses first, and then compare to that. So it's going to return false. 32 divided by 4 would be, what, 8? So that's way less than 129. So false does not equal to not true. So not true. So what's going to happen here is it's going to evaluate this side first because it has to. So not true would be false. And then when we have false is not equal to false, it's going to return false because technically false is equal to false. Let's try that. Yep. So down here, we have false here. Okay. True equals 4. All right, so this is showing that Boolean values do not equal truthy values. So obviously that's going to be false because 4 does not equal true. 4 equals 4, and true equals true. All right, so false equals, and then this is going to be a true. This is going to end up being coerced into a Boolean. So the question here is though are the string and is the number and string equal to each other? So it depends on the equal signs that we use. If we use 3 equal signs like this, it's going to check for the value and the type. So in this case, we have a number and we have a string. And so those are not going to be equal to each other. So that's going to return false. So this whole side is going to be return false. And then it's checking to see if false equals false, and it does. So this one actually is going to be true. And there you can see it be true down here. And this one, false equals, so now we're using the double equals here, and that does not check for type, so it's only going to check for value. And these do have the same value, string 847 and number 847, so they are equal. So this will be true. False equals true is false. So this one is actually going to return false. And finally, we got a kind of a difficult one here, but we'll go from left to right because we're dealing with OR, so only one of these has to be true. This is false. The opposite of true is false, so that's not true. We're going to start with the parentheses. So 100 divided by 5 is 25. And it's going to be, is it going to be truthy, or is 25, 25 is truthy, so not 25 would be falsy. So this is going to coerce the integer 25 into a Boolean false. False cannot equal 20, so this is also going to be false. The second thing here is false. And finally, 328 divided by 4 is probably 82. 8, yeah, it is 82. So this is 82 equals 82, so that's true. I think why. Oh, okay. So this whole this is all one side here. So out of the three of those, this one is actually true. This expression here, or this part of it. So the left side of this is going to be true, and it's going to short circuit this OR for false, and it will be true, I believe. So this should return true, and there it is. So this is just some examples of going through them and making sure that we understand what they are. I'm not even going to go through the answers because they're all, I just did the answers there. All right, write a function even or odd that determines whether or not even or odd. So we got the function there that determines whether or its argument is an even number. If it is, the function should log even to the console, otherwise it should log odd. For now, assume that the argument is always an integer. Okay, let's get an argument in here. And so even or odd, trying to think, I mean, I think we could just do an if statement. So if num remainder, I think we want to do 2, right? So if it can divide evenly into 2, equal, used to Ruby, equals 0, that means it's even. And then otherwise, I think this is all we need to do. There we go. And let's try it with some examples. So even or odd, 1. So we'll just do 2, 3, 4. 2, 3, 4. So, you know, it should be odd, even, odd, even. Let's see if that works. I should have done this earlier, but I didn't. Pause for a minute. Okay, so I just opened up this window down here, look for the results over there. So let's see what we got. Oh, nah, it's not gonna work. That's right, because I'm still attached to that. So hang on a moment. Actually, yeah. Okay, we're just gonna switch in this main window down here. So go ahead, here we go. And so we have odd, even, odd, even. So that does seem to work. Let's look at the answer real quick and we'll see if I missed anything. Okay, so I kind of wrote it out. Is there, yeah. Here in this answer, I used ternary operator, which works. But in my answer over here, I just wrote out the if statement. Either way, there's really no difference. It's checking to see if num divided by 2 has a remainder. If the remainder is 0, it's even. If there is a remainder, it's going to be odd. And it just logs that to the console. So pretty straightforward on that. All right, let's see this one. Let's improve our previous example, implementation of even or odd. Add a validation check to ensure that the assignment argument is an integer. If it isn't, the function should issue an error message and return. Okay, so I feel like that's pretty simple to do. We just make another if statement. If num, I don't remember. I don't remember what is it type of? Maybe. Type of num equals number? No, doesn't equal number, right? I think that's gonna work. I'm not sure. Console log an error message that just says must be a number, whatever. It doesn't really matter what the message is, and return. So we want to return out of there early. So let's see. Let's give an example of Let's give an example of not having a number here, and just put the string a there. It just says check the argument is an integer. Okay, so let's see. Didn't work for any of them. Yeah, I don't think type of is the right thing. Or maybe let me check what this might be. Hang on. Okay, so yeah, it's definitely not type of. I think it is integer. I don't know if it's written like that or if it's let's try it. I don't know. Okay, yeah. So I think it might be. We don't need this. Maybe let's try that. Nope. So let's do this. And then this is a function. I don't know. Let's try that and see if that works. Nope. Something didn't work. Let's find out why. Okay. So I didn't look at it closely enough. Let's check again. Okay, so yeah, I am still getting used to this about JavaScript, so we'll just, and I didn't look it up, but I should have. So that is how you call that. So it is a prototype, I guess, or I can't remember the type of function it is, but in any case, you have to call number, and then you have, I guess it's an instance. It's not an instance method. It's like more like a class method in Ruby, I think. That's the way I think of it. On the number class itself is integer, and although I don't think it's actually a class in JavaScript, so don't use that language, but that should work. Let's see. So it didn't work because, well, it did work, but it did backwards, I guess. So let's see. If, so we want to say not. Let's do that. And there we go. So odd, even, and must be a number for even or odd. Yeah. So yes, so that will work. And let's see the answer. So basically the answer just wraps, oh, see, we're also checking to see if it's an integer, so we should probably, yeah, it doesn't matter. But anyway, you can see the answer here. Does use this number dot is integer here. I don't know. I don't know if that's the best way to do it, but that's the way we're doing it here. All right, what does the following code log to the console and why? All right, so so we have a string that we're inputting here. 3. And okay, so it's going to log 113, 142, and product not found. All 3 of those. And the reason for that is because we don't have any break statements in these case clauses. So the first time it goes, it's going to say, does 123 equal to 113? And it's going to say, oh, no, they are the same type, but the numbers are different. So no, it's not going to equal. Then it comes here and says, oh, yes, it is the same type and the same value. So let's go ahead and basically just run the rest of the code. I don't know why it does that. It seems like a bug almost to me. But it does. And so it's going to run the rest of the code. And so that's what the output is going to be. And we can see that. So I'll just copy it here. And just do that. And we can see it down here. So product 2, product 3, and product not found. So to fix this, we need to add break statements here. And I don't know if we need a break statement there, but we definitely need them there. And then this will only give us the product 2, which is what we want. So this, I think it's called fall through or something like that. Can't remember the exact language, but it basically shows how you need to have these break statements in the case clauses in order to stop the execution. So let's see what the answer is. So yeah, we were right about that. Case clauses need break statements, so the execution of the switch statement doesn't fall through. Yeah, so it is fall through right here. From the matching case 113 clause to the clauses below. In this case, right. We can fix this by adding break statements to each case clause. Okay, so we did that. Let's keep going. Refactor this statement to use an if statement instead. All right, so that's fairly simple, I think. So we're basically saying if foo, right, then bar else, we're going to be calling this. So, and we're not in any context of function or anything, so I'm not going to put return. Oh, actually, you know what? There is a return statement there. Okay, so this is basically the same thing. So I think it's just making sure that we understand ternary operators. So basically, we're basically returning the results of this ternary expression or operator. And so we're checking to see if foo is true. If foo is true, then we're going to return the string bar. If foo is false, we're going to return whatever the return value of the QUX function is. So let's take a look at that. So if foo return bar, and yep, so that's exactly what I have there. All right, good. What does this code output to the console? So here we have, let's see, function is array empty, array. All right, is array empty? It's actually passing an empty array, so you would think, okay, yeah, that's going to be an empty array, right? So an empty array gets passed here, if array. So this is going to actually log not empty because as I mentioned earlier, JavaScript doesn't consider empty arrays are basically just of length 0. They're arrays that are truthy with the length of 0. And that's not what we're checking here. We're not saying if the length of the array is 0, then it's empty. We're saying if this itself is truthy or falsy. And since an empty array is actually truthy, will return a truthy value. The true statement, the true line branch of the if statement is going to run, and console.log not empty is actually going to be output. So let's go ahead and see that in action. And so yeah, there we go. So not empty down here. Yeah, pretty crazy that it does that. Yeah. But that's because an empty array is actually considered to be truthy. With the isArray empty function, we have an if statement with the local variable ARR as a condition. The value of the local variable ARR is an empty array, which is truthy. Therefore, the true branch of the if statement is evaluated. So yeah. Okay, write a function that takes a string as an argument and returns an all caps version of the string when the string is longer than 10 characters. Otherwise, it should return the original string. Example, change hello world to hello world, but don't change goodbye. So we have to count the number of characters in the function. So we'll call it long caps like this. And it's going to take a string and so ultimately we can do string to uppercase like that, and that's basically what we want to return if something is true, right? So if string dot length is greater than 10, longer than 10, that's what it says, then not sure why it does this, but whatever. Return. We want to return string dot uppercase. And I think otherwise we just want to return string as it is. So I believe that should work. We'll try it with some examples. Long caps. Hello world. Long caps. Goodbye. Let's try it with those two examples and see if it works. Right. So I have to surround these in console log statements because we don't have. I'm just gonna copy that. We don't have. We're not actually outputting anything, I guess, is my point. So maybe I should have done. Does it say return? Yeah, it does. It says returns in all caps. So yeah, so we have to output the return value. Otherwise, it's not going to output anything to the screen. So here we go. Hello world is capitalized. Goodbye is not. So that should be good. Yeah, that's exactly what I have. And it gives some other examples. And then there's a way to use a ternary operator, which is basically the same thing. So yeah, that works too. All right, last exercise for this section. Write a function that logs whether a number is between 0 and 50 inclusive, between 51 and 100, and greater than 100 or less than 0. All right. So we'll call it, oh, there is already number range. It gets a number. And we're going to check if, first let's check for if it's less than 0. Num is less than 0. Then what do we want? Console log, and then we're going to have to use string interpolation here in a string literal. Num is less than 0. Okay. And then else if num is, let's see, less than 50, less than or equal to 50. Then we're going to have num is less than 50. No, that's not what we're going to have. It is between 0 and 50. I wonder if num is less than or equal to 0. is between 0 and 50 inclusive. So no, it includes 0. So this would be, yeah. So this would include everything up to 0 or below 0. This is up to from 50 to 0. And, we got to add these semicolons there. Else if num is less than or equal to 100. So this will be 51 to 100. And we'll do this. Num is between 50 and, or actually 51. That's true. It's going to be 51. And then finally, we're going to have just this else statement because this is going to be anything over than 150 or greater than 100. So we'll have num is greater than 100. All right, so I think part of the thing with this problem is that it's checking to see if, I think it's testing whether or not we are following the order of the problem or if we're thinking about this in a more logical way about being like cascading downwards. So we start at 0 or cascading up, I guess, and we're checking in an orderly way. Whereas the examples given both are out of order and the order of the problem, the way it describes the problem is kind of out of order with putting less than 0 last. So if we're just following it from the problem, we might start with 0 and 50, 51 and 100. Might make it a little more complicated. Let's see if we got it right. So yeah, 25 is between 0 and 50, 75 is between 51 and 100, 125 is greater than 100, and negative 25 is less than 0. So yeah, we got all of those right. I'm going to check the answer real quick. And it looks like it is exactly the same. Every single word is exactly the same. Everything is the same. So, yep, got that correct. So, yes, so that is the end of that. Let me go up to the top here so you can see the link again. So there's the link. Those are the exercises that we did. It took a little while to do, but it's good practice. Keeps my mind fresh on this. And yeah, hopefully that helps. Thanks for watching.